SQLite is an open source relational database management system that is self-contained, serverless, and zero configuration. This type of database is used in embedded systems, especially in software applications. Now, unlike MySQL, which is just another popular traditional RDBMS, SQLite does not require a separate server process, but rather a library that provides the database functionality within an application itself. In this video, I'm going to walk you through how to implement SQLite in RStudio and also perform some data analysis using a very popular database dataset from Kaggle. But before we do that, I'm just going to switch to the visual tab here, just to make it much easier for presentation and data analysis. So to continue here, again, let's just look at some of the advantages and disadvantages of SQLite. Again, we've already mentioned this. Self-contained, meaning that we can store the entire database on a single file, which just makes it much easier to distribute and deploy to other different applications without us, making some complex configuration, which just lends us to the second reason here, zero configuration. Like MySQL, SQLite does not require any complex configuration as we're going to be seeing. We're just going to be using a library, very minimal setup. Okay, and for that reason, it's mostly used in small-scale applications or projects that require limited resources. Disadvantages here, again, limited scalability, meaning that are not very suitable for large-scale applications that require or have high concurrent users. This just puts a heavy write load on the database, right? Again, here it's very limited in terms of concurrent write operations. Doesn't support this, and that's the strength for MySQL, right? Can support multiple processes or threads. So why do we use SQLite in R? Again, very portable. We can, since it's kind of stored as a file, it just makes it easier to share, distribute, and sort of transport the data between different systems or platforms. Again, due to its lightweight nature and also efficient database engine, it's just ideal for applications with constrained resources, right? So, for example, mobile devices or embedded systems. And lastly here, it just provides a very seamless R integration, since we can use a library to just have some convenient interface in R. Okay, and from that, we can just load our data and perform data manipulation and analysis. That's just a feature that comes with that. Okay, so for those who just want to have more background and information about SQLite, you can actually go to the official website and read more about that. There's also this website that just provides you a little bit of different tutorials on how to use SQLite. Okay. Again here, so to begin our video here, quick overview about the dataset. So just going to be using the Titanic dataset. Again here, you can actually download it from Kaggle, which is just a repository for different real-world datasets. So once you download that, you can actually store it in your project, right? Just create a folder and you can store it under data. Again, just a quick overview here. So we have different variables, passenger ID, just a unique identifier for each passenger survived here, with 1 meaning that the passenger survived, 0, the passenger didn't survive. P class here, just the passenger's class, the Titanic, whether it was class 1, 2, or 3. And this will also depend on, this will also sort of dictate the type of price you're going to pay based on the passenger class. Okay, then the name of the passenger is a variable, sex, whether the passenger is male or female, age in terms of years, and so on and so forth. So the first thing we want to do here is to load the SQLite library. But before we do that, make sure you kind of install these two libraries, right? But what we're going to be using here is called RSQLite. So you can actually install it here using the graphical user interface here. So again, it so happens that it's available in the R repository, or what we call CRAN. So click on install and then repeat the same procedure here. For here, we just it's just a package that makes it much easier to kind of access the path for our data. And you can actually come and look for it here. You can see it's already installed using version 2.31. Here, again, it's just another package, version 1.01. So it's very important before you begin, you can always restart your session and clear output. Just make it much easier if there are any issues that can just clear the cache. So once you load the library, just click here to run that, or you can use Control Enter or Command Enter if you're using a Mac. You can simply just come here and run the current chunk. Okay. So the next thing is to connect to the database, right? To do that, we're going to be using this function here called DB Connect. So I'm just going to walk you through individually what this code line means. So the con here, essentially is just an this is just the, so in fact, the entire thing here. So we know this is the assignment operator. So we just assign a value to a variable named con, right? Okay. Again, the value on the right-hand side of the assignment operator will be stored in the variable on the left-hand side. Okay. But again, here, the DB Connect, right? SQLite here. So since we've already loaded this library, we don't need this, right? But essentially here it just says from this library, we want to access a specific member from this SQLite library. All right. So we use here double columns, right? But since we have that, we can actually remove that if you like. So I just want to be explicit here. So the DB Connect here is just a function, right? This function is provided from SQLite package, right? The DB Connect is used to establish a connection to the SQLite database, right? Now, inside this function call, we have this part here, right? So this kind of just specifies the type of database to connect to. In this case, we're going to be using SQLite with these two parentheses here, opening and closing bracket. Then we separate that by a comma. And then here, this is just a character string that specifies the name of the SQLite database file to connect to. So in this case, we call this Titanic .db, right? So this DB Connect function will attempt to establish a connection to this database file. So once we have that, we can now run this chunk. Okay. So the next thing now is to create a table. In fact, if you go to file here, you can already see that we've already created that over here. Okay. So once we have that, so the next thing is to actually create a table. So to do this, we're going to use another function called DB execute function. Okay. So again, let's quickly go over this code. So here, inside here, the DB execute. So this function call to the DB execute function is provided again by SQLite. So it's used to execute the SQL queries on a database connection. So the first argument here, as we've already seen, is just the database connection. So we have con here. So con here, we've already created the connection to the database, SQLite database, right? Again, so inside here, we now provide the SQL query, right? So again, this is a very popular SQL command, create. So again here, so this just, we're going to execute that, starts with create table, right? Then we specify the name of the table, which is Titanic, right? And then the opening parenthesis here indicates the start of the column definitions, right? So we have passenger ID, and then we specify what data type that is, integer, and we also specify whether it's a primary key, right? Then survived here, the data type is integer. So we keep going like that. Name here, we want to store the name using text. So this is just a different type of data. And then age here in terms of years, right? Going to be another data type in SQL called real. And we continue like that, each time separating that by a comma. And then we close that parenthesis, and we make sure you just have that double quotation mark. And once we run that, all this will be created. The table will be created inside this Titanic table, right? Okay, or rather this table will be created having these different columns. So let's go and run that. So again, here just says the table Titanic already exists. So I could also run this to just clear that. So again, this is another SQL command. So it just kind of drops or deletes permanently the table. So it just, how do we specify that? Drop a table and then we specify the name of the table. So I'll run this. So I can see now that's successful. So now when I run this again now, can see now we've created the table Titanic. Okay, now we already have our table. It's much easier now to enter some data. So let's go and add some data. But before we do that, I'm just going to load the data that I already have in my data folder. So if I come over here, so you can see here, already have some Titanic data set, right? So this is what I want to load, the Titanic data set. So if I open it here, you can see we already have it over here. So this is the Titanic data set we want to load. Okay, so to do that, so let's see. Okay, so to do that, I'm just going to use the here package here, data titanic.csv. So this is the file path. Once we do that, once we are done with that, the next thing is to now sort of write, insert into the table that we created, right? So here we're creating, loading the data into a data frame called data, right? And then we use this function called dbWriteTable. Again, this is just a function call, which provides is provided by the SQLite package, right? So this function is used to write data from R to a table in SQL database, right? So let's look at each of those. So here, again, we have to establish a connection, which we've already established here. So we just use this variable con, just establishes for us the connection to the SQL database. Then this Titanic over here, this is a string, or rather is a character string that specifies the name of the table in the SQLite database. We've already created that. So this is what it's making reference to. Yep. So, and then comma, and then data here. So the data here is just the R object containing the data that we want to write it to the SQLite table. And this data here, again, in our case here, this data is actually a data frame. Okay, it could be a matrix or it could be a table and so on and so forth. So it's already been converted to a data frame. So we specify that over here. Yeah. Then header equals to true here. This is an optional parameter, kind of specifies whether the data object contains a header row with column names, right? In this case, we're going to set that into true, meaning that the first row of the data object contains the column names, right? So if we go to a Titanic data set here, we can see here, at the top here, we have the column names. And then, of course, we now have the individual observations. Yeah. And then lastly here, we also have this command here. So this also is another optional parameter, kind of just specify the parameter separator used in the data object, meaning if it contains multiple columns, right? We want to set it to a comma, right? We want to indicate that we want to use a comma to you know, as a column separator, right? So you can see here for each column, we separate that by a comma. Okay. And then the row names here equals to false. Again, it's an optional parameter. This just specifies whether we want to write the row names to SQLite table. In this case, it's false, right? Meaning that the row name should not be written to the tables. And then here, end row just means how many, so how many rows do we need to write to SQL table in each batch. Okay, so this is a very useful parameter, so that especially if you have you're writing very large data set to the database, you can use a small chunks to avoid memory issues. So you can just say in batches of 100 until we kind of just finish. So in our case here, you know, we have more than 100, so we have quite a bit of, so about 900. So we'll just insert that in batches of 100, 100. Then lastly here, append equals to true is another optional parameter. So this just specifies whether we want to append the data to an existing table. okay, with the same name in the SQLite database. In this case, we set it to true. With what this means is that if the name Titanic, right, this name, if this name exists in our SQLite database, okay, so what that means, it will already exist, then the new data will be appended to the existing table. Okay, so let's go ahead and run this code chunk. So again, we can see here, okay, we need to run this. Then the next thing is to run that. Okay, so now we have inserted all the data into our table called Titanic. So now we are ready to perform some data analysis. But again, here, if you had more than 2 tables, we just use the C concatenate here, and you can pass 2 data sets, right? So CSV format or just as a variable. Okay. Again, here we can also insert the data into a temporary table instead of a permanent table. So again, we just use the same thing, only we can specify temporary underscore table. So if we run this, right, so it just says the table already exists. So I'm just going to use this to retrieve all the tables in the database. We use this function db list tables, then provide the connection. Once I print that, you can see we have 2 tables, Titanic and temporary underscore table. Okay. Now that we have that, we are ready now to perform some queries, right, to our data. So to do this, we're going to be using the db get query. So let me just highlight that. Again, this is just a function that's used to execute the SQL commands, right, and return the results at that data frame. So the first thing here to do is to use this function, db get query, right? Con here is our establish our connection to the SQLite library. Again, here we just use the SQL statement. So select here. So essentially here we use the select command, then the star here or asterisk. We want to select all the columns. Then we use the from here keyword. We want to specify, we want to get all these from our table here, the Titanic here. So we want to select all these columns, the values from all these columns, right? Again, once we do that, we use this, again, we want to limit that to 10, right? So when we run that, we can see we just extract the first 10 rows, right? Same thing like using R. When we use R, we use head, right? We just, you know, just kind of just, you're getting the first 10 observations. So if I say head here, then I pass my Titanic data set from the data frame. Yeah, you can see I just have the first 5 or 6 observations, right? So, to continue here, we can look at another example here. You can see here the good thing, we can scroll across, you can see the name, variable, all these are the names of the first 10 observations. Again, based on sex, the ticket, the fare, and so on and so forth. You can easily scroll across. Now, suppose we want to select only the columns for passenger ID, survival status, and passenger class. Again, we're just going to be reusing this db get query, establish the connection. Then inside this quotation mark, I'm going to select, then we specify the individual columns, right? So remember here, we're using this asterisk. Okay. So this asterisk just means we just want to select all columns. But if you want to select individual columns, then you have to specify that separated by a comma. So in this case, passenger ID, survived, P class, and you have to make sure that actually they correspond to these values, right? So if you put small caps, you might have an issue here. Again, so once we have that, we again specify from the table called Titanic. Then we use this limit clause to specify how many observations we want to return, how many results we want to return. So I ran that, and you can see here, we only extracted 3 columns and limited our observation to 3. So we can quickly have a quick table showing our results from our, from our command here, select command. Now, suppose we want to select only the data for passengers who were in the first class and survived, right? So here we're going to just select everything from the Titanic table. Then we're going to use this condition clause called where. Then we specify a condition. So the P class must be passengers from class 1, right? And we use this and, okay, the column survived equals to 1 as well, right? So this will only return observation for all passengers, right, from our Titanic table that came from class 1. You can see here, all these are different passengers from class 1, right? And also from the first class, right? I could change this maybe to want to know those who survived in class 2. Very simple. So you can see here, we have 174 rows, right? If we do from class 3, you can see there are 238 observations, right? So it looks like there were more people in both. Actually, there were more people in first class than in actually second class who survived. So essentially, that's what it means. Okay. Again, here we can also execute an SQL query to retrieve the average fare for class, right? Based on some condition, right? So here again, we're going to use the DB query, establish connection, then we select, right? But before we do that, we're going to use this method AVG, which just gets the average, and then we pass our column, right? Remember, this column has to be either real or integer. So because the average here only works on numbers or real values, right? So if you remember here, our fare here, actually, the fare here essentially is actually probably integer, right? It's actually a number, right? If you look here, actually it's a number, right? Numeric. So with that, then we use as AVG fare just to use it as an alias. So we want to store it as an alias, right? Called AVG fare. So by doing that, we're telling R that we want to store the results of this into this new column called AVG fare, right? And we want to extract all this data from the Titanic table and specify a condition using the where clause, P class equals to 3. So when we run that, we can see we have a new column that contains the average fare for all the, passengers who came from, or rather who actually were in class 3. So if we do for 1 here, again here, we can see that the average fare that was paid for by passengers in class 1 was $84, for example, if that was the unit of measure that was being used. So if we change this to 3, you can see that it was actually lower at 13, the average price that was paid for that class. So that's actually how to quickly, do some analysis using SQL statement. Very easy. So we establish the connection and we pass our SQL statement here. And then SQLite will just perform the analysis. We store this into a variable called result object, and then we print it out. Okay. And lastly here, suppose we want to select the average age of male and female passengers, not only if they have but only if they have a non-missing or non-missing age value. So how do we go about this? Okay. So to do this, again, it's very simple. We use a select statement, and then we specify the column that we want to extract from. So sex here will include either male or female. And then we want to get the average age, right? We want to perform this method on the age column, right? Average, we just get the average age from this column from the Titanic table. Pair age, and then we use this clause, right? Is not here. It's very useful for checking whether, actually it's just to check whether age does not have any null values, right? And then lastly here, it just groups the entire column sex, right? It groups this sex, by gender and male, right? So when we run this, we're gonna see how, so it just extracts from the sex column, we have female, and then it kind of computes the average here for this column, you can see the average age for those passengers who are female is 27 years or 28 years. Then the average age for male passengers was actually 30 years. So as you can see here, this query just quickly concludes for us or summarizes for us this question. So allows us to answer this question, right? You know, for example, if you were to ask, you know, what was the average age for the passengers, right? In terms of sex, who actually boarded Titanic. Okay. Another useful thing that we can do here during data analysis is aggregate data. Again, here we can use aggregate data using SQL commands. So for example, here, let's find the average age for female passengers, right? Male and female passengers. I think that's what we've already done here. So the next thing here, again, is to just get the count of all passengers who survived. To do that, we'll get the total number of passengers who survived. So we use this command here called count, and then in parentheses, we pass the asterisk. So this will just pull or do a count and return a numeric variable, right, or numeric value. So survived here equals to 1. So if you do that, it just returns a single value, right? And we can see here that all the passengers who actually survived were 684, right? If I change this to 0, then all these passengers who didn't survive actually was 1,098. So this means all these passengers actually lost their lives, right? Yeah. So and that's just, you know, a very powerful a command that can help you to aggregate the data really quickly. Yeah. And again, here we can also aggregate the data using count. So for example, here we want to aggregate and find all the passengers from the different class, right? And then want to group by class. So for example, we want to know how many passengers, right, were in the first class, how many passengers were in the second class, and how many passengers were in the third class, right? So to do that, we can use this. So you can see here what we just did. We want to select, we want to apply this on this P class column, and then we want to count all the values in this P class, right, from this Titanic table, and then group by class, P class. We know we have 3 classes. So for example, it will just iterate over this. So for the first class, it will get the value using the count. Second class will get that, and third class will get that. So as you can see, this aggregate function is very powerful. Task 7 here, we can also filter the data. Again, here is just using select statement. We've already seen that. We use the where clause to do the filtering. So again, here, we've already seen this. We just extract all the observations for passengers who actually survived, right? We extract all the columns, right, using asterisk here. Again, also, how do we order the data? So suppose we want to select all the columns from this Titanic table, but want to order by increasing the fare, right? So to do this, we just specify order by and then the column name. Then this can change. We can actually use descending or ascending. So by default, actually, I think it should be ascending. So, but let's just look at how it appears. So if we go to the fare here, so if I go to the next 10 here, you can see it's actually descending, right? But if you don't specify that, and I run this again, you can see by default here, actually, you know, it just doesn't show that. So, but if I do this, so what if I just want to do by ascending, right? So by ascending here, that means we start with the, so actually this is the default, start with the smallest and go all the way to the largest, right? So again, it's useful just to use this order by if you want to, and you can actually change that. It doesn't have to be fair. So, but depending on the column that you want to use. Yep. And then update data. Again, this is a useful feature. So for example, we want to set the fare, right, to 30 for all the passengers where ID equals to 1. But to do that, let's first of all look at all the passengers where ID equals to 1. So You can see their fare, their current fare here is actually, so let's see, this is what, so we have, let me just move this over here. Let me switch to visual here, see whether we can be able to see that. So we can see the fare here is actually 7.25, right? So we're gonna use the update statement here. Again, the syntax is update, then the table name, then we use the set here, set the column that you wanna apply to. So this is fare. We wanna change that to 30, right? And then we use a condition here where passenger ID equals to 1. So if I run this, again, you can see we updated 2 records, right? Observations. So I run this again and can see here the fare has been updated to 30. If I change this again to maybe 50, again, you can see this is actually updated. So update statement is very powerful, especially when you want to quickly apply or update. You know, if you're a HR, for example, you want to probably sort of apply a bonus for the year, for maybe all the employees. So update statement can easily do that, and you can actually perform complex queries for that. So what if we wanted to delete data or some data, right? We use the delete clause, right? To do that, so suppose we want to delete from this table Titanic, where age is null, right? But to do that, let's now look at, first of all, extract all the data where the age is null, right? So to do that, so it just appears that we have 354 rows, right? So if I go to age here, you can see we have a lot of passengers didn't indicate their age. So maybe we want to do some data analysis here, right? We want to do some data cleaning. We can remove this, right? So again, this is a reserved keyword. So here where age is a column is null, just checks for NAs, right? So if we perform this, again, we just use the delete keyword, right, from Titanic where age is null, right? So that will just drop all these 354 rows. So if I go run this again, you can see it doesn't return anything. So 0 rows were found. So delete is very useful, especially when you just want to remove specific observations or rows from your data that meet a specific condition. So lastly here, let's say we want to back up our data, right? So we just use the file.copy, and then we want to copy the name of our database, titanic.db, that we already created at the top here. If you recall, during the connection here, right, we want to create a copy of this. So we use the file.copy again here, and then we specify the name of our backup, right? So the useful feature, the good thing about this, we'll just store on a local storage. So if we go back here, I can already see that this is actually included at the bottom here. So I don't know why it's not showing, but yeah, there you go. So we have Titanic backup here. So so if I delete this, so for example, I'll just delete that. So let me just delete that. No, click no for data. So I just want to delete that. All right. So the next thing here is to actually create that backup, right? So again, what just happened here? So we just want to make a copy of that. So, but since I already have this back tab, so I'll just go to my location here. So I'm just going to delete this, the backup. So delete that. So when I rerun this again, you can see now that's true. I go back here, you can see already that's been backed up. Okay. And once you're done, you can now detach your database. So this is just a good practice, right? So once I disconnect the connection, we're good to go, right? And this just concludes our demo video on how to use SQLite. We've already seen how to load the required libraries. We've seen how to sort of load the Titanic dataset that we've used for this video, how to create a connection, how to create a table, in our SQLite database, and we've seen how to perform different SQL statements like insert, how to insert data into the table, load it from the data frame, and write it into our table, right? And then from there now, we're able to use different SQL statements, right? Like select, delete, update, just to perform different analysis, to answer different questions, right? So again, this is just a quick high-level overview and demo of how to use SQLite databases in R. You can actually literally do so much. It has so much flexibility. All right, and that concludes our video.